Good morning everyone. Myself Rupam Kundu and I am Subham Kundu. We are from DAV Public School Baryatu Ranchi and this is our project the Solenoid Reciprocating Engine. Our projects based on the subtopic Historical Development with Current Innovation. Now let me introduce this project of ours. The solenoid engine was first discovered about 2 centuries ago by American scientist Joseph Henry in the late 1830s. It has potential, yet it was never realized and it just kind of lost in the pages of history. But we have analyzed that this engine can prove to be a big game changer in today's era. It can help us achieve sustainable locomotion and can have many applications in the modern world. So now let me describe the various components used here. Here there are 2 solenoids which are made up of copper wire, 2 solenoid holders which are aluminium, and there are 2 reciprocating pins which reciprocate inside the solenoid and are made up of iron, 2 connecting rods made of stainless steel, and connectors are there between connecting rods, reciprocators and crankshaft. These are made of brass. The crankshaft is made of any kind of alloy. There are 2 crankshaft bearings which are of stainless steel. The commutators used here are made of brass and the wires are copper. This is a 20 volt 3 ampere power source which is used to power this engine, and it is a socket to transfer the power into the engine. A switch is used to break and open the circuit as per our needs. The whole project is made on a wooden board. Now let us understand the working of this model. As you can see, there are 2 solenoids. Whenever they are fed with electricity passes through the copper wires, they produce electromagnetism. And we can see that the reciprocators are made of iron. As we know, iron is ferromagnetic and is attracted to magnetism. Hence, in this case also, the iron reciprocators get attracted inwards, and this is the main or the only power source of this engine. This acceleration produced in the reciprocator is what causes the motion. But only unsystematic activation of the solenoids cannot enable the cycle. For that we have 2 commutators. What they do is they systematically close and open the circuits of one solenoid each. When one circuit of the solenoid is open, other is closed. It ensures that only one solenoid acts as it at a time and can provide proper and efficient power to the system. But you can observe that the engine produces reciprocating motion, which is of little use. Hence, we have this combination of crankshaft and connecting rod. These 2 together help or enable us to convert the reciprocating motion into rotatory motion, which is more useful. Now take a look how it runs. The engine now is provided with 20 volts and 3 ampere current. It is running at 1000 rpm now. This engine has many advantages. First of all, it is eco-friendly. You can see there are no emission being caused by this engine. So this is totally eco-friendly. Secondly, there are no induction motors used. Induction motors which are used today have large permanent magnets which are very costly and hence increase the overall price of electric vehicles. And since this engine has the mechanism similar to the IC engines we use today, so it is very easy to implement them, and the process will be very much cost effective, which will take very less time to implement it on the large scale. The areas where it can be implemented and it can be applied is that it can be used to power automotives because it can produce decent torque. It will lead to cheaper EVs and more durable ones as well. Moreover, this can be also used to transform an initially internal combustion engine into an electric vehicle by just swapping, because both the systems are similar to each other. The transmission is similar. Only difference is the power source. In IC engines, it is cylinders in which combustion or internal combustion happens. But in this setup, electricity powers it. Hence, just swapping the cylinder with solenoids will transform the vehicle into an EV. Moreover, it produces torque to a greater extent. Hence, it can be used easily in railway locomotives which have continual supply of electricity. It can also find a scope in ship propulsion and heavy machine industries. Look at how the engine is running. We hope we could provide an insight to this model. Thank you.